In this lesson, we're going to investigate how to find extrema on some given interval. Now, extrema is nothing more than another way to state a maximum or a minimum value, extreme values. Now, if you have a continuous portion of a function on some closed interval between a and b, where those are x coordinates, then f has both a maximum and a minimum on that given interval. Which may seem a little peculiar because you might be thinking, how could a graph reach a high point and a low point on any interval that's given? Well, the reason is because these maxes and mins could potentially occur at the endpoints of that given interval. Now, anytime a change in direction occurs, similar to maybe the top of a parabola, that might be considered a smooth transition, or a sharp turn where it might be the bottom of an absolute value function. Anytime a change in direction occurs, increasing to decreasing or decreasing to increasing, then we've reached what we refer to as a relative extrema. And relative extrema can only occur as when the derivative is zero, which means that we've reached a flat tangent line, or when the derivative is undefined, which means that we've reached a potential cusp. Now, we don't know necessarily that it's a cusp because derivatives could be undefined at vertical asymptotes as well. But that's why we're going to have to test to determine whether or not these are, in fact, relative extrema. So let's take a look at a basic function, y equals sine x, and just on the interval 0 to 2 pi. Now, we should recognize that this function has a maximum at pi over 2, because it's reached a high point. The graph changed from increasing on the left side to decreasing on the right side. Now, in terms of calculus, we should recognize that that implies that the slope changed from positive on the left side of pi over 2 to negative on the right side of pi over 2. Now, we say that the maximum occurs at the x value of pi over 2, but we also say that the maximum value is the y coordinate of 1. So we have to make sure that we're drawing the distinction between the two. We never say that the maximum is pi over 2 comma 1 as an ordered pair. We make the distinction between whether or not it occurs at an x value or the maximum value is a y value. Let's look at the minimum value on that interval. Notice that there's a minimum here as well because it reached a low point. It changed from decreasing, which means that the slope is negative, to increasing, which means the slope is positive. If that ever happens, then we've reached a relative minimum. So the minimum occurs at x equals 3 pi over 2, while the minimum value is the y coordinate of negative 1. So we need to define something referred to now as a critical number. So if we know that f is defined at some x coordinate, then f prime of c, which is the slope at x equals c, equaling 0, or the function not being differentiable at x equals c, which means the derivative is undefined, implies that we have a critical number at that x coordinate. In other words, if we know that the derivative is 0, or the derivative is undefined, then we know that those are potential locations for where maximums can occur. Relative extrema can only occur at critical numbers. So therefore, if we ever want to find the maximums and minimums of a given function, we simply have to find the derivative and set that derivative equal to 0 or undefined. So let's take a look at this example, just a basic quadratic function. And we're only looking at the extrema on the interval from -2 to 1. So we're not looking at the entire graph. We're only looking at this smaller interval. So let's look at the steps in order to find the extrema on some given interval a to b, a closed interval a to b. The first step is to obviously find our critical numbers in that given interval. Now notice that we only really have to find the critical numbers on the open interval a to b, not necessarily including -2 and 1, because we'll evaluate those endpoints after we find our critical numbers. So we find our derivative, which is 2x plus 2. And it said that in order to find critical numbers, we find out where the derivative is equal to 0 or where the derivative is undefined. Now this derivative is a linear function, so it's never undefined, but some derivatives are going to be fractions, at which point I would have to set the denominator equal to 0 as well. And therefore the only critical number occurs when x is equal to -1. Now what you should note here is that -1 is in the interval from -2 to 1. So at this point, we're going to evaluate the function at each critical number to find the corresponding y values. But then we're also going to evaluate f at each endpoint to find the given y values. So let's look first at the critical number. If I evaluate f of x at -1 by plugging in -1 to each of the x's, I get 1, -2, -4, which gives me a y coordinate of -5 on my graph. Let's find the left endpoint. The left endpoint is x equals -2, and so when I plug in -2 to my function, I get 4, -4 is 0, -4 gives me -4. So right now it appears that the minimum value is -5, and the maximum value is -4 because it's higher. But we also find the right endpoint by plugging in +1, which is the right endpoint on this interval. And I get 1 plus 2, which is 3, -4 is -1. So in order to find the absolute maximum and the absolute minimum on this given interval from -2 to 1, we simply look for the lowest y value, which is -1, or the highest y value, which is -1, and that gives me the absolute maximum, while the minimum, the absolute minimum value is -5. Now we say absolute because we're saying that there is no point higher and no point lower than these two values. Now we could see that if we look at the graph of this given interval. We could see that this is a parabola, but we're only graphing it between x equals -2 and x equals 1. And you can see that these orange points indicate the important locations. The only critical number occurred at x equals -1 because it's a horizontal tangent line. The slope is 0. But the absolute maximum and minimum could also occur at the given endpoints. We could see that the right endpoint was the highest, while the critical number happened to be the lowest. So absolute extrema occur when there are no points higher or lower on that entire interval, which is why we stated earlier that on any given interval, there will always be an absolute maximum and an absolute minimum, assuming the function is continuous. Now we want to differentiate this from relative extrema by recognizing that relative extrema only occur at critical points, and those are points when in that general area you've reached a high or low point. So notice that I would refer to x equals -1 as where a relative extrema occurs, because in that general area I could see that this is the lowest point. Therefore, if we're given any function but we're not given an interval, we can only find relative extrema because at that point we could find the critical numbers and evaluate those at each individual x coordinate.